Okay. A mathematical relation exists when two mathematical values are related in some way. A, as we learned yesterday, relation is any set of ordered pairs. From what you learned yesterday, fill in this blank. The blank of the relation is the set of x coordinates. The domain of the relation is your set of x coordinates. The range is the set of y coordinates. Relations can be represented as shown below. And you saw 3 out of the 4 of these yesterday. We can write them as ordered pairs. We can have them in a table. They could be on a graph. The new piece today, or something you haven't seen before, is called mapping. And they label them as inputs and outputs, which really just mean your x's and your y's. Okay, so input, you plug in for x, and you calculate for y. How you create a mapping is you list all of your x values least to greatest, all of your y values least to greatest, and you use arrows to show which ones match up. So negative 2x connects to 3y. The point is negative 2, 3. 0x connects to negative 1y. 0, negative 1. So these arrows tell you this x belongs with this y, this x belongs with this y. Okay, number 1 F word in math that we hate, fractions. Thank God we don't have to deal with those today. But we deal with the second F word in math. A function is a specific type of relation that assigns exactly one output to each input. To make it very simple, that's supposed to be an asterisk. X cannot repeat. I don't care about y. Y can do whatever they want. Doesn't matter to me. X cannot repeat. You cannot have two x's that are the same number. Okay? So they give us an example using mapping. On the left, this mapping is a function. 2 goes to 1, 4 goes to 3, 5 goes to 4, 9 goes to 7. Each input only goes to one output. Now, they don't have to go straight across. It could have been 2 to 7, 5 to 1, 4 to 3, 9 to 4. It's just the fact that each input only goes to one output. This one says it's not a function. What in this mapping tells you this is not a function? Grady? Bingo. 2 has 2 arrows coming out of it. 2 goes to 1 as well as to 3. And our rule is x cannot repeat. When you have 2 arrows coming out of it, that means x was repeated. Okay, so let's try this on our own. Bottom left. Don't shout it. Everybody get your answer first. Determine whether this is a function. Somebody raise their hand and tell me yes or no, it's a function. Zach?
No, it's not a function.
Why not?
Because one of the inputs goes to 1.
Perfect. Right here is the issue. Not a function. Input of 1 repeats. And I want you to have that explanation so that in 4 days when you go back to look at this, or on Thursday night when you're preparing for your quiz and you go back to look at this, you're like, gosh, I can't remember why I said not a function. Not a function because the input of 1 repeats. Okay, go to the mapping on the right. Raise your hand. Who can tell me yes or no a function? Davion?
It's not because 4 goes to 2 numbers.
Perfect. Not a function. Input 4 repeats or goes to 2 different outputs. We never want a number in the input or the domain to go to 2 separate ranges. Okay, flip it over. What happens if they give us our information in a table? In this top left table. Function, yes or no, by the raise of your hand, somebody. Calix? Yes or no? Function. Yeah? But 4 and 9 repeat. Bingo! Y's don't matter. Good job not falling for me. My trick here. Y doesn't matter. Do any of these x values repeat? No. So this, yes, is a function. Yes is a function. Table top right. Somebody raise your hand and tell me yes or no. No? Okay, Aspen, let's get it. Very good. If we ignore the output, there are 2 2's in the input, so not a function. Input 2 repeats. I'm going to show you one other type of explanation you may see, or one other form. They may list for you some ordered pairs, and they'll put a brace and then go like 3, 2, negative 5, 7, 4, 2 in a brace. So my question to you is, if I have these 3 ordered pairs, is this a function, yes or no? It is. Which letter matters, X or Y? X. So if I just go through and I circle the X's, I don't care about the Y's. Do any of those X values repeat? No. Therefore, yes, a function. Ignore the Y. The Y means nothing to us today. So in the beginning, we talked about 4 different ways they can show us information. Ordered pairs, we just talked about. Table, we just looked at. Mapping, we looked at. The last part is a graph. To determine whether the relationship shown on a graph is a function, we apply the vertical line test. And remember, vertical is up and down. Up and down. For every value of x, a vertical line passes through no more than 1 point on the graph, then the graph represents a function. That sentence is always a little confusing to me, so I focus on the last sentence. If you draw a vertical line and it goes through more than 1 point on the graph, it is not a function. If you have a vertical line that goes through more than 1 point on the graph, it is not a function. Okay? This yardstick is going to be like what you do with your ruler. If you have your paper laid on your desk, and you put your pencil down on your paper in the vertical format. Okay, lay your pencil flat on your paper just like this, straight up and down. If I drag this across this graph, will my vertical line represented by your pencil ever cross this graph, this blue curve here, more than once? No, it only crosses the blue graph one time, always. Right here, I'm only crossing the blue line once. It's twice, right? Whoops. You see this? Up here and up here, it's crossing through your pencil, yes? So if I represented or drew a vertical line, if we just use the grid line, right? It's technically going through my graph there as well as here. So my question to you is, function, yes or no? Not a function. So you can use your pencil at thinking about a vertical line, or just think about if you drew a bunch of grid lines up and down. Okay, let's look at this one. If it crosses the graph or has the graph going through your pencil more than once, not a function. If it only goes through your pencil one time, yes, a function. What do you say on that one? Yes or no? Yes, a function. No matter where you draw a vertical line, it's only touching at 1 point. Try the bottom 2 on your own. We're going to come together and share our answers in a minute. Use your pencil or use the grid lines to draw vertical lines up and down. If it's ever touching the graph at more than one location, not a function. Go ahead, give your explanation, Sage. What are you going to tell her?
I can't explain it. It's hard.
Somebody else. Give a different explanation. Because sometimes I think like I explain it and it makes sense, and it doesn't sometimes.
So like it curves and it makes like an oval thing.
Okay.
So if you put your pencil where those dots are, where the line is, it goes through the slice.
So your graph is really this whole shape, that whole blue curve. So if I just randomly drew a vertical line, we're going to use this. Does my ruler intersect that graph at more than one spot? Intersect means they cross, right? So this curve meets it here as well as down here. 2 times touching, not a function. If I put it here, how many times does it cross? Just the one spot right here. What if I put it here? One spot right here, or here. It doesn't loop back, see that? So it's only touching my vertical line one time. If I go to the bottom left, who can tell me yes or no? Take that out of there. Who can tell me yes or no? Calix? Why? If I drew a vertical line, like followed that grid line, I touch 2 points, right? By definition, if it touches 2 points, not a function. Gabby? Bottom right. I'm holding out for you. Don't tell her.
I'm not gonna tell it.
Okay.
It's not a function.
Why?
It loops.
Draw a vertical line
Where?
anywhere that it's going to touch more than once.
Okay, Gabby. So like if you draw a vertical line, it touches.
Sometimes it works in people's brains and sometimes it doesn't, so I'm glad you're asking. Okay, if I trace this vertical grid line right here, it touches the blue curve here, here, and here more than one time, right? Therefore, not a function. Okay, I'm going to give you 2 more that have been tricky for people today. Will?
Not a function.
Why?
Because it hits like the same spot.
Right here?
Yeah.
And technically over here? You're actually wrong. This is a function. Yes, it is. Because the open circle isn't actually a point. An open circle represents being infinitely close. Okay? But it actually does not occur there. So when I drew these 2 lines, which should have been like, ooh, I think there's an issue here, because one of them is open and one of them is closed, really the only point is the closed circle. So this is, yes, a function. Now, if all of those circles were closed, 100% not a function. But because it's open, it doesn't actually occur there. Okay? So how about this one?
No. Yes, it's a function.
Will, they're all against you.
No. Yes,
No.
it's a function. No, it's not. It's not. It's not.
Why not?
It's not.
Oh, it's not.
It's not.
Right in the middle.
Okay, so right here, technically it's only hitting here, right? Ms. Hoff, you just told us at the open circle it doesn't hit. But what about here?
It's both.
It hits both. Therefore, not a function. Yes. Not a function. Some people then were like, okay, every time there's an open circle, I'm just going to say yes. Well, that's not always the case. Okay? If you just think about drawing grid lines, if you were taking your pencil, are you going to touch the graph or the blue line And don't think of this as two separate graphs. This whole thing is one graph. Does that make sense? Yes, there's three separate chunks to it, but it doesn't matter if it touches any blue part, not a function. Today, your brain wants to hurt you, and people are going to get super frustrated, okay? Because the answer literally that you're clicking is either function, not a function, or yes or no. So when you click it, check, and it tells you that you're wrong, you instantly want to say, oh, which one's wrong? Well, if I tell you which one's wrong, have you really figured anything out on your own? So people get super frustrated, like, you're not even helping me. I will answer all your questions. I will not tell you which one is right and which one is wrong. Okay? Some of this is just going to take practice. All right? If we all get done before the end of the hour, I will play Kahoot with you. Everybody log in, go to your desktop, and nothing else. I need to check something. Log in, go to your desktop. I need to check something.